Well, hello there, everybody. Let's talk about, systems of linear inequalities. Let's talk about what they look like, how they work, what solutions are, where solutions are, and then last, how to find a solution by graphing. So I went ahead and I printed off an example of one, right? I just did a Google search for systems of linear inequalities. This is one of the first ones came up. It's pretty good example. So typically, the unshaded region, like over here, you see how it's all in white, there's nothing that's shaded. Usually this is not where the solutions are, right? So not solutions, not a solution right here, not a solution anywhere in this area right here, right? So for example, this point right here, not a solution, that's not a solution, not a solution, not a solution. Okay, the only place that has a solution is the area that's in between here, underneath this line, and above this dotted line. So this part right in here, that is a combination of this orange and this blue color, right? This purplish color thing right here, this right here is where the solutions are. So for example, 4,1 is a solution. Now, in case you forget, a solution is a value that makes a statement true. So here are the two inequalities that we have, right? So to demonstrate, let's do a couple of these, right? Let's pick, this is a solution. Anything over here is not a solution. Anything in here is not. And even though, like for example, this is a solution, it's on the solid line, so it's part of the answer. So this is an answer to this line right here, and it's an answer to this inequality over here. So the shaded area blue, anything to the right of that is a solution to this equation, and anything on this line or below it is a solution to this inequality. So this fits both of those. This point right here fits both of those issues. So let's do a couple of examples right here. Let's see some that are and some that aren't. And for example, this point right here is not. So we're going to see this one is not. We're going to see that this one is, but this one is not, right? And this one is, and all of these are not. So everything in here is a yes. Everything outside of here, now everything outside of this little area right here, everything outside of there is a no. So again, in order to be a solution to a system of equations, the point has to work for both, right? So let's show you how that does right here. Let's talk about checking a solution. So let's see this one right here. That's 4, 1. Now we're going to see 4,1 is a solution because it's going to be true for both of them. So I'm going to do this first one here. So if I put 1 is greater than 3, that's 4 times 5. Well, that's going to be true because 1 is greater than -7. So that part's true. And if I plug this into the other inequality, so I get 1 is less than or equal to 4 minus 2, that's true also. 1 is smaller than 2. So it works for both. That's why it's a solution. Every single point in this area is going to be a solution unless it's on the dotted line. If it's on the solid line, it'll work. So watch. Let me let's write these two things over here again real quick. So we've got y is greater than -3x plus 5, right? And we've got y is less than or equal to x minus 2. Okay, so dotted line in the shaded area is a no. Solid in the shaded area is going to be a yes. So this one right here is 3, -4. So we're going to show that that does not work, and we're going to show that this one, which is 5, 3, does work. Okay? And the reason that is because the dotted line is not included, right? So I'm going to go ahead and do this. -4 is greater than -3 times 3 plus 5. So this has to work for both. It might work for one, but it has to work for both. So watch, check this out. Let's see. -4. Oh, it's not greater than -4. It's equal to, but it's not greater. So that's a fail right there. Since it fails one, it doesn't matter. It would have to work for both. Now let's try this one. I'm going to plug that in. 3 is greater than -3 times 5 plus 5. So 3, that's -15, right? Plus 5 is -10. 3 is greater than -10. That one works. And then let's try this one right here. 3 is greater than or equal to, because it's equal to 3. So see, it works. If it's on the solid line and in the shaded area, it works. If it's on the dotted line in the shaded area, it doesn't work. But for example, just for clarity, this point right here would be a no. It's on the line, it's on the solid line, but it's not in this double shaded area. So idea so far, only in the double shaded area are solutions existing. Everywhere outside of there, no dice. Okay, so we talked about what a system of linear inequalities is. We talked about how to read the graph. We talked about how to check. So now let's go ahead and talk about how to solve one by graphing. So I've got this system of inequalities right here, and I've got my graph. So what we're going to do is we're going to go ahead and graph this, shade it in. I'll show you some shortcuts to help you to be efficient at this. It's going to be great. So let's go ahead and do this, right? So we have two equations. We're going to graph one, and then we graph the other. Don't make the 2 dots for this one and then 2 dots for that one. It just causes you lots of trouble. So this is slope-intercept form. The way we do slope-intercept form, you start with the y-intercept, and then you count the slope. Y-intercept's -3. The slope is 1/2, so we're going to go up 1 over 2. Up 1 over 2. I'm going to go down 1 and left 2. And this one is a dotted line. See, it's a dotted line, right? So I'm going to go ahead and make myself a dotted line right here. By the way, if you want some practice and a lesson on this, if you don't have one, that's pretty good. I think you could check out onteachingmath.org. I'll leave a link to the lesson for this particular topic there for you. All right, so now let's talk about which way this is shaded. This one is shaded above. It says y is more than all of this. So more for y is in the up direction. So this one's going to be shaded this way, right? I'm not going to make shading that looks like this, not by hand. It's too sloppy. But I'm going to do it this way right here. I'm going to shade up in a minute. All right, so you'll see what's going to happen when this in a way. Anyway, everything above this is an answer. Anything below is not an answer to the first inequality. So now let's check the second one. This is standard form. The easiest way to graph in standard form, if you remember, your x-intercept is c over a. Your y-intercept is c over b. And if you need, your slope is the opposite of a over b, right? That's your slope. Anyway, 10 over 5, well, that's 2, so 2. And then 10 over -2 is -5. This one's a solid line. So we have 2, -5, solid line this time. All right. Now, let's talk about which way this one is shaded. This one's really tricky, actually. You see, it says less than, less is down, but it's the opposite of, so it's going to be above. The opposite of y, so it's going to be up, right? So I'm going to do everywhere on here. I'm just going to like put a point. And the way this goes up, because it's such a steep line, like people want to think left or right, but no, think up or down. So it's going to be shaded over here. So can you tell where the shading is going to be? Do you see it has to be above this line and above this line? So things over here, no dice. Things in here, no dice. Things in here work for this line. Things over here work for this line. This over here doesn't work for anything, right? So our shading is actually going to be in this area right here. You would never really use a graph this big on a test, but anyway, that's what it would look like. There's our shading, is right in there. So everything in here is an answer. Everything that's in here and on this part of the line. So from example, I'll show you. Everything from here on this line, from everything from here up is an answer. And everything in here is an answer, but on the dotted line, no answer. So anyway, man, it's a lot of information there. We got through it rather quickly. I hope it's been helpful. Have a good day.